We're going to add to our stuff from last week where we identified the independent variable. We wrote a function, and then we solved for sum to get one value. So today we're going to talk about having possibly a specific domain and range for our function. So for each problem, we're going to find a reasonable domain and range. Domain, remember, is what we can plug in for x. Range is our input. Range is our output, what we're going to get after we plug in that value. So on our Bell work, the domain for number 3 was 12. That's what we put into the function. And then the range was $30. That was the output. So we're going to have we're going to choose reasonable domain and range for these specific problems. So your first problem says Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. How many of you have ever been in the situation where you're supposed to sell so many tickets? Yes. Okay, so you can relate to this. We're going to write a function for the total amount collected from ticket sales. So we're going to break this down again into our dependent variable. And remember that, cover that up. What are we trying to find here? In reading, it's going to tell us what our function needs to be. It says write the function for the total amount collected from ticket sales. So that's your dependent variable. We're trying to find the total amount for the ticket sales. So go ahead and write that in for your dependent variable. Total amount collected from ticket sales. That's what you're going to write on this sheet. That's the dependent variable. So far you've sold $20 worth, but you still have 4 more tickets, so that could increase, possibly. So total amount collected from ticket sales is your dependent variable. What is the total amount going to depend on? How many tickets you sell, the number of tickets sold. So we're going to call that our independent variable. Okay, function. So we know we've sold $20. Take a guess at what you think the function will. F of x will be what? What do you think that's going to be for your function? It's similar to our problem that we had on the Bell work. There was a fee to get in the park and then so much per ride. Here we know he has sold how much so far? $20. Nobody's going to take that away, right? That's a constant. But then we have $2.50 per ticket. A lot of times when it has the per word, the word per, that's going to be where you're going to put your variable with. So f of x is going to either be, we could write it 2 ways. You could say we know the $20 plus 250x, or you could put the x term first and then add 20. No, you're going to add 20 to that. Either way is correct. Okay. So the next thing is we're going to talk about the domain. So now the domain, we're looking at what we have here, that f of x equals 2.5x plus 20. X stands for the number of tickets sold. Okay, so how many does that Manuel have left to sell? 4. But are we guaranteed he's going to sell all 4? He could sell 4, he could sell 2, 1, 3. He only has 4 to sell, right? So that's all the max he could sell. What's the least amount he could sell?
0.
0. So could he sell 1.5 tickets? No, he couldn't, because you can't get in on half a ticket, right? Okay, they don't tear them in half and say, hey, yeah, you can buy half a ticket, and then, no, that's not how it works. So the domain is going to be 0, 1, 2, 3, or 4, because he could sell 0 tickets, 1 ticket, 2 tickets, 3 tickets, or 4 tickets. So the domain is the set of those 5 numbers, 0 through 4, those 5 integers. So put that down. Okay, so when we had the domain on our Bell work, our domain we said was what on the third problem? What did we plug in? 12. So to find the range or the output, we have to plug each of our domain into our function. So that's going to look like this. We're going to figure out what f of 0 is, and then we'll figure out f of 1, f of 2, f of 3, f of 4. So write this down first. This is the first step in finding our range. We're going to evaluate f of 0. So what do we get when we input 0? Somebody said it. What'd you say? 20, right. 2.5 times 0 is 0. So we add 20 to that, and our answer will be 20. Okay? Or 20 what? Dollars is what it will be. So now we need to plug in what's another input that we could have? Well, let's go in order. Yes, 4. But then we would also have to do 3, 2, and 1. So let's go in order. I want you to evaluate all of those. F of 1, 2, 3, and 4. Plug that into the function and let's see what we get for each one of those. And that will help us define our range. So there are the values when we plug in 0, 1, 2, 3, and 4. Hopefully those are correct. Okay, but it's not enough just to do this part. We have to state our range in set notation, just like we did for our domain. We put it in the squiggly, 0, 1, 2, 3, and 4. We need to do the same, and I've got to write it big because I'm using my fingertip here. And so it's going to look like this. So squigglies, and you'd start with the smallest one. Hold on, let me move this. It's going to be 20. Then we'll go 2250, 25, 2750, and then 30 in the squigglies. And that's how you would state your range. Sorry, it's not super neat there. Okay. Okay. So now we have a specific domain and range rather than just one, and we have a different variety. So she could either earn $30 for whatever fundraiser she's doing, or she could stop and just earn $20, but then if she can't turn in her tickets without money, she's going to lose some money, right? Because she's going to have to pay for it herself. $10 on her own to pay for those tickets. Don't want that to happen. Okay, let's look at the next problem. On our next problem, we have a telephone company charges 25 cents per minute for the first 5 minutes of a call, plus 45 cents for a connection fee. Just to make the call, they're going to charge you 45 cents. So you're going to write a function for the total cost in dollars of making a call. So again, we want to identify our dependent variable and independent variable. Notice how on the top it kind of told us what the dependent variable was, right? It said find a function for the total amount collected from ticket sales. And what happened to be our dependent variable? The total amount of ticket sales. But that depended on the number of tickets sold. So here, fill in your dependent and independent variable based on that. See what you can come up with. Cell phone bill, then they're like, you went over the minutes, or you went over the data allowance thingy. Anybody ever have that happen to them? Okay, so some of these problems that we're dealing with deal with like bills that you might get as an adult, or maybe before then, that you'll have to worry about. And it's going to be important for you to understand how that bill was calculated. So here we have a telephone company, it could be a cell phone company, charges 25 cents per minute for the first 5 minutes and a flat 45 cents connection fee. So what do we have for the dependent variable? What did you write for the dependent variable, James? Okay, so dependent variable is going to be, now the connection fee is a given, right? We know what the connection fee is, correct? So does that change on anything? Doesn't depend on anything. So the dependent variable is going to be the total cost of the call. That's what we're trying to figure out. What's the total cost of making a call? The connection fee is a constant. We know what it is. Dependent variable, we don't know what it is. We don't know what the total cost is going to be. So what do we have for the independent variable, Gemma? What do you think the independent variable is in this case? Well, that's kind of what we're figuring here, the total cost of making a call. What's that going to depend on? Not the amount of calls made. How long the call? The minutes, right? So how many minutes, the number of minutes is the independent variable. Because you're getting charged 25 cents per minute. When you see that per minute or per ride or per ticket, that's your independent variable, okay? That's it. It's giving you verbal or English words to help you give you cues as to what's the independent and what's the dependent variable. So something per, whatever happens after that per is your independent variable. So per minute. Okay, so now we're trying to figure out a function that we could write that uses our dependent variable and our independent variable and anything else that we know. So James, you said we automatically have a 45-cent connection fee. That doesn't change. That's a flat amount, right? So our function f of x needs to include that. So you could start with f of x equals 0.45. That's going to happen no matter how many minutes, correct? Plus a certain amount per minute. So that's where we use our 0.25 per minute. So we could write our function. Ooh, notice I changed it to g of x. Is that okay?
No.
Why not? So, hey, this brings up a great point. You can name your function whatever you want. You can use whatever letter you want. We've been using f of x. We could use g of x, h of x, m of x, t of x, doesn't matter. We can use whatever we want to name it, but what has to be true is that g of whatever this variable is here needs to be in our equation. So if you put f of x, that's fine. It's okay, it's still good. But sometimes we have to compare two functions and we don't want them both to be f of x. One of them is going to be f of x, the other one we have to name something else because they're not the same function. Okay, so what's the maximum number of minutes that we could have on that we're going to get charged for on this? 5, right? It says it goes up to 5, the first 5 minutes. So it's not going to say, I'm going to charge you for 1.3 minutes. It's going to charge you per minute. If you go over that minute, you're going to get charged probably 2 minutes, the next one up. So you could either, what's your domain going to be? What could we have? What if you make the call and they don't answer it?
You still made the call.
You still made the call. Did you talk at all? So we could have 0 minutes, correct? Or 1 or 2 or 3 or 4 or 5. So our domain that we could use for x could be one of those 6 numbers. So I spelled it out up here. If you understand where these 0, 1, 2, 3, 4, and 5 come from, all you need to put is that, the set notation. But if you're not quite sure where we got that, then put the 0 minutes, 1 minute, 2 minutes, 3 minutes above it, okay? So go ahead and write that as your domain. We know our domain. We're going to evaluate our function for each of those domain, which means we're going to figure out what g of 0 is, g of 1, g of 2. So on the range, now you're going to plug those values in. So please do that and figure those out. And then put your range in set notation right like what we've got here. Okay? So at least write this first one out. Well, I'd like for you to write all of them out so that you can understand, because oftentimes we teach each other, and if somebody doesn't understand something, then you'll have in your notes exactly what's going on and you'll be able to explain it.